I see the problem. Scikit-learn's IsolationForest, a tool for finding unusual data points, is incorrectly identifying too many points as unusual. We need to adjust the model's settings to fix this. Let's figure this out together. I'd increase the contamination parameter. This tells the IsolationForest how many anomalies I expect to find. If it's flagging too many, it thinks the percentage of anomalies is too low. By increasing this value, I'm telling the model, hey, expect more anomalies. This should reduce the incorrect flags. Simple and effective. I would also consider increasing the n_estimators parameter. This parameter controls the number of trees used in the IsolationForest model. More trees usually lead to more stable and accurate results. Think of it like this. More trees give the model a more robust view of the data, leading to better anomaly detection. It's like having more opinions to get a better consensus. This would actually make things worse. Decreasing this parameter would make the model even more sensitive to anomalies, increasing false positives. That's not what we want. We need to be more generous with the model's allowance for anomalies. This is usually a bad idea. Reducing the training data won't help. It'll likely make the problem worse because the model won't have enough information to accurately learn the data patterns. We need to work with the data, not reduce it. The problem is that the IsolationForest model is incorrectly identifying way too many data points as anomalies. I need to figure out why this is happening and how to fix it. This means the model is not accurately distinguishing between normal data and anomalies. I can try increasing the contamination parameter. This parameter tells the IsolationForest how many data points it should expect to be anomalies. If I set it too low, the model will think almost everything is an anomaly. By increasing it, I'm telling the model to expect more anomalies, which might fix the problem. I can also try increasing the n_estimators parameter. This parameter controls the number of trees used in the IsolationForest. More trees generally means a more robust and accurate model. A more accurate model should be less likely to incorrectly flag normal data points as anomalies. Decreasing the contamination parameter would likely make the problem worse because it would tell the model to expect even fewer anomalies. This would increase the number of data points flagged as anomalies. Reducing the amount of training data is unlikely to help and could even hurt the model's accuracy. The model needs enough data to learn the normal patterns. Reducing data might make it harder to identify anomalies correctly. It could even increase the false positives. I'm focusing on how the hyperparameters, specifically contamination and nestimators, affect IsolationForest's performance in anomaly detection. The goal is to understand how to tune them to get accurate results. Think of contamination as your guess of how many anomalies are present, and nestimators as the number of trees in your forest to make that guess more robust. My IsolationForest model is incorrectly identifying too many data points as anomalies. This means my model is too sensitive, classifying normal data points as outliers. I need to adjust the model to be more accurate. I can increase the contamination parameter. This tells the model to expect a larger proportion of anomalies. It's like saying, hey model, I think there are more anomalies than you initially thought. I can increase the nestimators parameter. This will use more trees in the forest, resulting in a more stable and robust model. More trees typically leads to a more refined prediction. Decreasing the contamination parameter would worsen the problem because it will tell the model to expect fewer anomalies, making it even more likely to flag normal data points as outliers. Reducing the training data would likely reduce the model's ability to accurately learn the underlying data distribution and may lead to more false positives. It's not a good way to fix this specific problem. I'm tackling a common issue with IsolationForest, a machine learning algorithm used for detecting anomalies. We're adjusting its parameters to improve its performance. The goal is to find the optimal settings for this algorithm so it accurately identifies the unusual data points without incorrectly classifying normal data. Think of it like tuning a radio. You need to adjust the knobs to get the perfect signal. I'm facing a problem where my IsolationForest model is identifying far too many data points as anomalies. This means that my model has too many false positives. It incorrectly considers many normal data points as unusual ones. The challenge is to fix this issue. Let's dive in. I can try increasing the contamination parameter. This parameter tells the IsolationForest model what proportion of the data it should expect to be anomalies. If I set it too low, the model will be overly sensitive and flag too many points as anomalies. Increasing it means I'm telling the model, hey, it's okay. There might be more anomalies than you initially thought. This helps reduce false positives. I can increase the n_estimators parameter. This parameter controls the number of trees in the isolation forest. Much like a forest is made up of many trees, more trees generally make the model more robust and accurate, resulting in a better prediction of the anomalies. A stronger forest is less likely to make mistakes. Decreasing the contamination parameter would worsen the issue, making the model even more sensitive and leading to even more false positives. I wouldn't try this approach. I definitely should not decrease the amount of training data. That would give the model less information to learn from, reducing its accuracy and potentially causing more false positives. It's like trying to build a house with fewer bricks. The result won't be very strong or stable. Based on my analysis, the best options are to increase the contamination parameter and increase the number of trees, n_estimators. These adjustments directly address the issue of the model incorrectly flagging too many data points as anomalies. I see the problem. Your IsolationForest model is mistakenly labeling too many normal data points as anomalies. This means it's too sensitive and needs adjustment. I recommend increasing the contamination parameter. This tells the model to expect a larger percentage of anomalies in your dataset. Think of it like this. If you tell the model to expect more troublemakers, it will be less likely to wrongly accuse the innocent. I also suggest increasing the number of trees, n_estimators, in your isolation forest. More trees mean more votes, leading to a more reliable prediction. It's like having more judges in a jury. A more informed decision is likely. Don't reduce the contamination parameter. That would make the model even stricter, and result in even more false positives, normal points wrongly identified as anomalies. Reducing the training data is usually bad for the model's learning ability. It won't solve your problem and might even make things worse. A smaller dataset could lead to the model overfitting to noisy examples. I'm focusing on how we can adjust IsolationForest settings to improve its accuracy in identifying anomalies. IsolationForest is a machine learning algorithm. It's a type of algorithm that's used to detect anomalies in data. The hyperparameters are the settings we can tweak to make it better at its job. The problem is that the IsolationForest algorithm, from the Sklearn library, is incorrectly labeling too many normal data points as anomalies. It's like a faulty alarm system that's going off too often. I'd suggest increasing the contamination parameter. This parameter tells the model what percentage of the data you expect to be anomalies. If it's flagging too many, you should tell it you expect more. Increasing n_estimators means you'll use more decision trees in your isolation forest. More trees help make the model's decisions more reliable and less prone to errors. Think of it like having more expert opinions. That will give a more robust consensus. I wouldn't recommend decreasing the training data. It's usually better to have more data, not less, to properly train the model and achieve better results. It could make things worse because it would teach the model on a biased dataset, leading to incorrect results. The IsolationForest model is incorrectly identifying many data points as anomalies. I suspect the model's internal estimate of the proportion of anomalies is too low. I would increase this parameter. This directly tells the model to expect more anomalies, thus lowering the threshold and reducing the number of false positives. Think of it as adjusting the sensitivity of the model. A higher value means the model will be more lenient in flagging something as an anomaly. You can also try increasing the number of trees in the isolation forest. More trees provide a more robust and accurate estimate of anomaly scores, potentially leading to a better separation between normal and anomalous data points, thereby improving the accuracy of the model. I wouldn't do this. Reducing training data usually hurts performance and makes it more likely that the model will incorrectly flag points. This isn't a solution. It's more likely to make the problem worse. This would make the problem much worse. I need to increase, not decrease, the model's expectation of how many anomalies exist.